This utility pole is being stressed to the breaking point. Loaded with thousands of pounds of force, it's got to hold up even if the wires it would carry get dragged down by ice or fallen trees.
It failed at 7,700 pounds.
A pole that can carry 4 tons before failing is unheard of. So is one that will bend back into place after 2 tons of force. This composite fiberglass and resin pole is the strongest on the market, made by Calgary's Resin Systems Technologies.
Over 2.5 times what its class equivalent wood, steel, or concrete pole would be.
In the Quebec ice storm of 1998, with these poles, the ice would have brought down only the wires, making repair faster, the blackout shorter. Gianellia led the building of the bridge to PEI in 1997. Thinking about corrosion and salt water led him to look at composites.
In the barrier walls for the bridge deck.
Research into composites for power grids, bridges, and highways is underway at this lab in Winnipeg and across Canada.
They don't corrode inside and break up the concrete. They are light, so you can transport them cheaply.
I think in the long term, you'll get the cost effect will be such that they'll dominate.
Mufti says composites are catching on across Canada because they cost less in maintenance.
The leaders are Quebec and Ontario.
These cost more than regular poles, but they're cheaper when you factor in installation and shipping.
We never make anything that's anything other than a net 30 feet.
Like a giant nesting toy, poles are made by putting together sections that come in lengths that are easy to ship.
If I want a stronger 45-foot pole, I take that off and I put that on.
Various combinations make different heights and strengths. RS now sells in 7 countries. It's been built into design software used by 80% of U.S. utilities, a sign of how composites are catching on. Dave Sims, CBC News, Calgary.